This video is about probability rules. Okay, so we have 4 main rules. Okay. So first of all, any probability has to be a number between 0 and 1. I can't tell you how many times people on the exam have given me an answer for probability that's not between 0 and 1. If you get a number like 1.5, you know you did something wrong. Okay, so all probabilities have to be between 0 and 1. Now, all your possible outcomes, if you add them all up, have to have a total combined probability of 1. That makes sense, right? If you're talking about like flipping a coin, you have 50% heads, 50% tails, that has to add up to 1 or 100%. So probability of the entire sample space put together has to be 1. Now, the next one is new. So if two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. So if A and B are disjoint, that means nothing in common, then the probability of A or B is going to be just the probability of A plus the probability of B. And the probability that an event does not occur is 1 minus the probability that the event does occur. So we'll use this little c for complement. So probability that A does not happen will be 1 minus the probability of A. So that's written down here. So probability of disjoint, also called mutually exclusive, means two events are disjoint if they have no outcomes in common. This means they can never occur together, or we call this mutually exclusive. So if I was to do Venn diagrams, we usually do a big rectangle for the sample space. This is everything possible. And here's my event A. That means event B will be over here, and they don't overlap at all. There's nothing in common. Complement, the complement of any event A is the event that A does not occur, which we write A with that little c. So if I was to draw this, we'd have my S for my sample space. Here's A in here, and then A complement would be everything outside of that circle. So absolutely everything outside the circle would be A complement. Okay, so A is inside the circle, A complement is everything outside the circle. So what does this look like? Here's a probability model for color preferences. We have each color with the probability that someone chooses one of those colors. So first of all, does this probability model follow the first two rules? Okay. Well, our first two rules is first is every number between 0 and 1. So 0.42, 0.14, if I look at each of those probabilities, each one is between 0 and 1. So each probability between 0 and 1. The next rule says that they should all add up to 1. If you add them all up, you should get 1. So let's try 0.42 plus 0.14 plus 0.14 plus etc. up to 0.02. Go ahead and put this in your calculator and we get 1. So each probability is between 0 and 1. They all added up to 1. So we follow our rules. Now, the next two rules are just more useful. So like, what is the probability that a person's favorite color is blue, purple, or orange? So I look up blue, purple, orange. Now these colors don't have anything in common. We're not overlapping because you can only pick one favorite color in this scenario. So I can just add up the probabilities. So probability of blue or purple or orange is going to be equal to the probability of blue plus the probability of purple plus the probability of orange. So this would be 0.42 plus 0.14 plus 0.05, which gives me 0.61. So that's the probability that it's blue or purple or orange. Now, what is the probability that a person's favorite color is not brown? So there's two ways you can do this. You could go through and add up every single one that's not brown. So all the ones that are not brown would be these and these. So if I add all of those up, I'm going to get 0.97. But that looks like a lot of work. So let's see if we can find an easier way to do this. So the probability of not brown, or I could write it as brown complement with that little c for complement, will be 1 minus the probability that it is brown. Okay. So if you want the probability of everything that's not brown, you can find brown and subtract that from 1 because everything has to add up to 1. So this will be 1 minus the probability of brown is 0.03. So this gives me 0.97. Notice that's a lot easier than adding up everything that was not brown. And we'll use that complement rule all the time to save time. Let's try another example. Let's say our first quiz consists of 3 true or false questions and you didn't study. If you blindly guess at each question, find the sample space and probabilities of each sample space outcome. So we have 3 questions. Each question we can either get, let's do right, R for right, or W for wrong. Since I don't want to actually write it out every time, we'll use some abbreviations. So the first question you can either get right or wrong. The next question can be right or wrong. Next question is right or wrong. Next question can be right or wrong, right or wrong, right or wrong, right or wrong. So for our sample space, we have the possibilities of right, 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 wrong. So I'm just following along the branches. Right, wrong, right. Right, wrong, wrong. So these are all of my possibilities. And to find the probability of each one, notice it's true, false, and we didn't study. So each of these possibilities should be equally likely because each outcome or each question, you have a 50% chance of getting it right, 50% chance of getting it wrong. You didn't study, it's just everything should be equally likely. So this means there are 1, 2, 3, 4, 5, 6, 7, 8 possibilities. So the probability of each one, if they're equally likely, should be 1/8. They should all be 1/8. Now, if each question is worth 1 point, what are the possible scores you can get and the probability of each possible score? So, my possible scores are 0, 1, 2, or 3. 3 questions means those are my scores. So to get a 0, let's go back up and see which things will give us a 0. To get a 0, I would have to get wrong, wrong, wrong. So that would just be 1/8. But to get 1 point, let's find everything that will give us 1 point. So everything with 1 R. So this one has 1 R, this one has 1 R, and this one has 1 R. So that means there are 3 of them. Remember, each of these had a probability of 1/8. So 3 of them means that it would be 1/8 plus 1/8 plus 1/8. So 1/8 plus 1/8 plus 1/8 equals 3/8. Now for 2 possibilities, look for everything with 2 R's. So here, here, and here. So that's 3 of them again, so 3/8. And finally, to get 3 points, you have to get them all correct. Right, 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 which is only one way to do it, so 1/8.